NENOMATICA, where mathematics meets YouTube excellence. Example: we will solve the inequality step by step, following the exact structure shown on screen. First, we display the problem in bold orange. Step 1. Start with the given inequality. We simply rewrite it to keep it in view. Step 2. Combine the left side over a common denominator of 6. Step 3. Distribute the -3 across the parentheses in the numerator. Step 4. Combine like terms in the numerator to get -p plus 6 over 6. Step 5. Express the right side with a common denominator of 4 by writing -4 as -16 over 4. Step 6. Clear denominators by multiplying both sides by 12, the least common multiple of 6 and 4. Step 7. Simplify the multiplication on both sides. Step 8. Distribute again to expand both sides. Step 9. Move the p terms to the left and the constants to the right. Step 10. Combine like terms. Step 11. Divide both sides by -5. Remember to reverse the inequality when dividing by a negative. Step 12. Simplify the division to get p greater than or equal to 12. Great work following the structure exactly as shown. Simplify the division to get p greater than or equal to 12. Example: we will solve the compound inequality exactly following the shown algorithm. We first split the compound inequality into two simple ones using the rule a less than or equal to b less than or equal to c if and only if a less than or equal to b and b less than or equal to c. Now we solve the first inequality. Add 7 to both sides, then divide by 3. The solution is m greater than or equal to 3, which we record as set d 1 equals the interval left bracket 3 comma plus infinity right parenthesis. Next, we solve the second inequality. Subtract 2m from both sides, then add 7 to both sides. This simplifies to m less than 21. Record this as d2 equals open interval minus infinity comma 21. Finally, take the intersection of the two sets. The overall solution set is d equals d1 intersection d2, which is left bracket 3 comma 21 right parenthesis. First, display the example label and the problem statement. Then we proceed through the 10 steps: distribute, group, get common denominators, simplify, clear denominators, simplify again, compute, divide by a negative and reverse, reduce the fraction, and finally write the solution set. Step 1. Apply the distributive property. After distributing, the inequality becomes 2x over 5 minus x over 2 plus 3 over 2 is less than or equal to 2x over 3 minus 3 over 10x minus 3 over 5. Step 2. Group like terms by moving all variable terms to the left side and constants to the right side. Step 3. Combine fractional terms using a common denominator. Step 4. Simplify the numerators and denominators. Step 5. Clear denominators by multiplying both sides by 30. Step 6. Simplify the multiplication. Step 7. Compute the right-hand side. Step 8. Divide both sides by -14 and reverse the inequality. Step 9. Simplify the fraction. Step 10. Write the solution set interval. Quick example. In this video, we solve a linear inequality exactly following the steps shown in the reference solution. Quick challenge. Predict the first algebra move we will apply. Step 1. We clear denominators by multiplying both sides by 6, the least common multiple of 3 and 2. Step 2. Simplify. 6 over 3 becomes 2, and 6 over 2 becomes 3. Step 3. Distribute. 2 times 1 minus 2x gives 2 minus 4x. 3 times 3x minus 1 gives 9x minus 3. Then write the minus 6x at the end. Step 4. Combine like terms on the right. 9x minus 6x equals 3x. Step 5. Move terms. Subtract 3x from both sides and subtract 2 from both sides. We obtain -7x is less than or equal to -5. Step 6. Divide both sides by -7. Remember, dividing by a negative flips the inequality. So x is greater than or equal to 5/7. Here is the solution on a number line. A closed bracket at 5/7 and shading to the right towards positive infinity. Therefore, the solution set is the interval from 5/7 to infinity. We start with the example exactly as presented. Problem statement. Solve the inequality x times the quantity x minus 3 is less than the quantity x minus 1 squared. Step 1. Expand both sides. Multiply x times x minus 3 on the left, and expand the square on the right using the identity. Open parenthesis, a minus b close parenthesis squared equals a squared minus 2ab plus b squared. Then write the expanded inequality. Step 2. Use the addition and subtraction property of inequalities. Subtract x squared from both sides. Step 3. Again by the addition property, add 2x to both sides to collect x on the left. Step 4. Divide both sides by -1. Because we divide by a negative number, the inequality direction reverses. Show the division explicitly. Then write the final simplified inequality. Let us graph the solution x. We will reconstruct, check, and solve the inequality seen in the image using a clear, rule-based step-by-step method. First, let us show the example, and the problem is bold orange math. Step 1. Expand both squares using the identities. A minus b quantity squared equals a squared minus 2ab plus b squared, and a plus b quantity squared equals a squared plus 2ab plus b squared. Step 2. Remove parentheses and distribute the minus through the second group. Step 3. Combine like terms on the right. X squared minus x squared cancels to 0. 1 minus 9 is -8, and -2x minus 6x is -8x. Step 4. Add 8x to both sides to isolate x terms on the left. Step 5. Write 8x as 16x over 2 and combine over a common denominator of 2. Step 6. Divide both sides by 21 over 2, which is positive, so the inequality direction does not change. Final solution x is less than or equal to -16 over 21. Here is the first example. Read the problem, then we set variables and build the inequality. Step 1. Define variables and express Alex in terms of Fred. We let S be Fred's goals. Then, A equals 3 plus S. Step 2. The total is less than 9. Substitute A equals 3 plus S into S plus A is less than 9. Step 3. Simplify the left side. S plus S makes 2S, and the constant is 3. So we get 2S plus 3 is less than 9. Step 4. Subtract 3 from both sides to isolate the term with S. Step 5. Divide by 2 to solve for S. Interpretation. Fred scored fewer than 3 goals, so S could be 0, 1, or 2. Using equals 3 plus S, Alex could have 3, 4, or 5 goals. Now, the second example. We follow the same structured approach. Define, set inequality, simplify, and interpret. Step 1. Let G be the number of girls and B be the number of boys. Since there are 8 babies, G plus B equals 8. Therefore, B equals 8 minus G. Step 2. Girls are more than boys, so G is greater than B. Substitute B equals 8 minus G to obtain G greater than 8 minus G. Step 3. Add G to both sides to obtain 2G is greater than 8. Step 4. Divide both sides by 2, giving G is greater than 4. Interpretation. The number of girls must be strictly greater than 4. Possible integer values are 5, 6, or 7. We exclude 8 in this context to ensure both girls and boys are present. Example. We are given the inequality 2 times open parenthesis z minus 5 close parenthesis is less than or equal to 4z. We will test z equals 1, z equals -5, and z equals -12. Step 1. Substitute z equals 1 and simplify to check truth. Step 2. Substitute z equals -5 and simplify. Step 3. Substitute z equals -12. Watch the comparison carefully. Conclusion for the inequality checks. Z equals 1 and z equals -5 satisfy the inequality, while z equals -12 does not. Now, the wire factory problem. The production cost for X meters is C equals 60x plus 170,000. The selling price per meter is 400. We want the minimum X so the factory does not lose money. Step 1. Profit equals revenue minus cost. With price 400 per meter, revenue is 400x. To avoid loss, we set profit greater than or equal to 0. Step 2. Distribute the minus sign and combine like terms. Step 3. Move the constant to the right and divide by the positive coefficient 340. The inequality direction stays the same. A number line view. All values from 500 to the right work, with 500 included. Summary. For the inequality checks, z equals 1 and z equals -5 satisfy, while z equals -12 does not. For the break-even problem, the factory must produce and sell at least 500 meters to avoid loss. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.